Okay, so we've learned about parallelograms already, but we're going to learn a lot more today about it. So let's review on what a parallelogram is. Let me grab that, grab this. I mean, technically that's a parallelogram, but when we see a parallelogram, it usually looks something like that. Whoops. There we go. All right, so there's a parallelogram, and we're going to learn some characteristics of parallelograms. We're going to learn some information, what's true. What do we know so far about a parallelogram? Just by definition. So by definition, what do we know about this if this is a parallelogram? What did we say? It's got four sides, but that's really not the definition. Okay, what's specific about this if this is a parallelogram? If I said this was a parallelogram, what could you tell me about it? Just right now, sitting in front of you without any marks on it whatsoever. All sides are parallel? Which two sides? The opposite sides, right. Okay, you have two sets. Listen to how I say this. You have two sets of parallel sides. The opposite sides are parallel, okay? Two sets of opposite parallel sides, or whatever. I don't know. But these two sides right here are parallel. How do I show parallel? Put a little arrow, not tick marks. Tick marks mean it has the same length, okay? But put the arrows. That means that's parallel. By definition, okay, the opposite sides are parallel. I'm just going to write that down. The opposite sides are parallel. And that's how I show parallel when I write a little symbol. Just two little up and down marks, that means parallel. We've talked about that before. So by definition, that's what we know. Everybody good? All right. Let me show you something. I'm not going to give you the reasons why, because of time and just because I have a feeling you probably don't care. All right. I'm going to tell you something else, and this is one of our theorems. We can prove it. I got it in my notes. It's proven right here in my notes, but I'm just going to give it to you. That's the only thing so far that we know about parallelograms. But by this first theorem, we're going to learn a few things. So here are some theorems. I'm not going to go through, tell you what the number of the theorem is and stuff like that, but here's something else that we know about parallelograms. Is everybody ready? A lot of talking over here. Need to watch and pay attention. So we know that the opposite sides are parallel, but somebody actually said this earlier when I said what's true about the opposite sides. But by this theorem, the opposite sides are actually equal to each other in length as well. So this length right here and this length right here are equal to each other. And this length right here, the length of it, if I measured it, Mar, face the front, stop talking. So this left side right here and this right side right here are equal to each other in length as well. So very, very simple. I doubt I'll give you anything this easy on a quiz or a test. But if I told you that this side was 3, what is this side down here going to be? It's going to be 3, okay? What if I said that this was 2? What's this side over here going to be? It's going to be 2, all right? I'm not going to put that on a quiz or test. That's way too easy. What do you think that I'll probably do, though? I'll probably say don't write this down, because I don't know if this comes out nice and even or not, okay? But I might tell you that side right there is 3x minus 5, and I might tell you this one is 2x plus 1 or something like that. What would you do if I gave you something like that? You'd set them equal to each other. That's right. Everybody see that? That's the kind of stuff that I would give you on a quiz or a test. So what do you need to know so far? You just have to know that the opposite sides of a parallelogram are what? Not just parallel, but equal. So let's write that down. So the opposite sides, this is all dealing with parallelogram, so I'm not going to write parallelogram every single time, okay? The opposite sides of a parallelogram are what? Equal, okay? So that's our first theorem. It's pretty easy, isn't it? So far, yeah. Here's another thing they tell you. Everybody watching? Look at this angle right here. Just take a wild guess. Let's change colors. What do you think might be true about the angles? Exactly right, okay? Amaya got it? So this angle right here, I guess I should put some letters here, shouldn't I? Instead of saying this one here, that one there. So let's call this A, B, C, and D. All right? Everybody watching? So look, if I told you what angle D was, what else could you find? Angle B, that's right. So angle D and angle B are equal to each other. All right? Again, if I told you this was 50 degrees, what's this angle? 50 degrees. You got it? Here's something else. Angle A must equal what? Angle C. Really easy. Okay? So again, what does this theorem say? It doesn't say opposite sides are equal. It says what? Opposite angles are equal. Okay? That's important too. There's something else. Let's do this in a different color. Look at this angle A and angle D. What do you think might be true about those angles? Remember, this top one and this bottom one are parallel to each other. Agreed? Do you remember that chapter we did parallel lines cut by transversal? Yeah? So what if I had two parallel lines cut by a transversal? Remember this? What did I say about this angle right here and this one right here? Are they equal to each other, first of all? Now, look at it. It's obvious they're not equal, isn't it? What kind of angle is angle D? It's an acute angle. Good. What's angle A? It's obtuse. Is there any way that they're equal to each other? No, it's impossible for them to be equal to each other. But according to this that we learned a couple, 3 chapters ago, whenever it was, okay, what do we learn about these? We call these consecutive angles. Remember that? Consecutive interior angles? What was true about the consecutive interior angles? They're not equal. Give me a word, though. You're right. They do add up to 180. They're supplementary. Very good. Okay, they're supplementary to each other. So what's true about angle A and angle D? They are what? Supplementary. But what does that mean, Neil? They add up to 180. Okay? You guys getting this, right? I'm giving you stuff you're going to have to know. And you're going to get on the test. You're going to be like, I don't know how to do this. Why? Because of right this second. Right this very second, you're not paying attention to me. That's why you're not going to be able to get it. I'm talking to the people who are not watching me and are talking while I'm talking. That's who I'm talking to. So if your name fits, then that's fine. Shh. I'm upset for you. I want you to learn how to do it. You should be as upset as I am. Why am I more upset than you about your grade? You should be the one that's upset. You should be the one that's paying attention, writing this stuff down, and not talking while I'm talking. All right, enough of that. I'm tired of this. Let's do this. What do I know about these? What do I call them? They're not opposite angles. They're not opposite sides. They're what? Consecutive. I'll write the whole word down. So the consecutive angles are what? They're not equal to each other. What are they? They're supplementary. I'll just put that. Okay? The consecutive angles are supplementary, which means what? A and D, angle A and D add up to what? 180. What about A and B? What do they add up to be? 180, because they're also consecutive angles, consecutive interior angles. All right? What about B and C? They're supplementary. They add up to 180. What about D and C? They're also supplementary. Those are your 4 consecutive interior angles. So anytime you have an acute angle and a supplementary angle in this situation, in a parallelogram, they always add up to 180. All right? Everybody got that? So, I mean, look, I could have said that this was like 3x plus 1, and this was 2x minus 5. I don't know if this works out. Don't do the math on this. Don't even write those down. But how could you solve for x, and how could you find those angles? What would you do to this one and this one? Would you set them equal to each other? No, you would do what to them? Add them up and set them equal to what? 180. That's right. Now, again, I don't know if this works out nicely. I just made those numbers up, okay? But I would add those 2 up, set them equal to 180, do some math, right? Do your algebra, solve for x, then plug it back in. All right, the same kind of stuff that we did earlier today. Everybody understand that? All right, let's see what else we got. Yeah, we already got that. 1 angle and 4 angles, a rectangle. I'm not going to worry about that one. Let's do this one. I'm just trying to pick out what I think you're going to need. There's a couple things we could kind of gloss over. So we only got 5 minutes, so I need to do this. All right, so let's make this kind of look like a parallelogram. All right, and I'll tell you what, let's just extend this out just a little bit so it doesn't look like a rhombus. Okay, what I'm going to do is I'm going to connect two vertices, and we have a name for that. I think we might have talked about that before. I can't remember what class I've mentioned it. See that one right there? I give that a name. Have I talked about what that is before? I'll talk about it now. Those red ones are called diagonals. All right, so those are called diagonals. When I connect from one opposite angle to another, okay, make a straight line, those are called diagonals. Now, here's something that's true about a parallelogram. Let's go yellow. Okay, now check this out. These are diagonals of a parallelogram. This white thing right here, that's a parallelogram. Okay, so what do I know about a parallelogram? The opposite sides are parallel. They're equal to each other. I know the opposite angles are equal to each other. I know the consecutive angles are supplementary. I know a bunch of stuff just from the last few minutes about a parallelogram. But here's something about the diagonals. Now watch very carefully. Let's call this ABCD again. And we'll call the point in the middle, they call it M. They use M for a reason. So check this out. Look at AM and look at CM. What do you think, just off the top of your head, without really knowing why, what do you think might possibly be true about the length of AM and the length of CM? That they're equal to each other, exactly right. So I could put a little tick mark here, a little tick mark here, all right? And it is true that they are equal to each other. What else do you think might be equal to each other with the diagonals? Say it. BD? Well, BD is that whole diagonal. That whole diagonal is not equal to this whole diagonal. Okay, that is not true. But what did I do here? This was being bisected, wasn't it? Split in half. So what do you think this is happening to that one? Same thing. So DM, exactly. DM and what? MB are equal to each other. Okay? So what does this theorem say? This theorem says that the diagonals, let's write it down, the diagonals of a what? What was this picture to begin with? What was it called? It was a parallelogram. What can I say about those diagonals? What do? They split each other in half. What's the geometry word that we use when something splits something in half? Bisect, exactly right. So the diagonals of a parallelogram, what do? They bisect each other. So this diagonal bisects AC. Do you see it? DB bisects this one. And AC bisects DB. So they bisect each other. Now, does that mean that all four of these segments are the same? No, because the diagonals themselves are not equal. AC does not necessarily equal BD. Everybody see that? This one looks a little shorter, doesn't it? AC, then BD. All right? So they don't equal each other, but they do what? They do bisect each other. So that's really, really important. Okay. Well, I'll tell you what. I'm not going to collect this homework, but you should be able to get started on it. Okay, I will assign it tomorrow. I don't know what I said in the lesson plans, but I might have changed it. So here's what it is. It's section 6.2, and this is what it's eventually going to be. It's eventually going to be 1 to 17. My guess is, I don't have the book in front of me. I don't memorize every problem. My guess is you should be able to do most of 1 to 17, if not all of them, right? And then I'm giving you 21 to 24. Okay, so both of those sets you're going to eventually have to do. do as much as you possibly can up to the point where we taught today. All right, and if we didn't cover it, obviously you don't have to do it. I'll assign it to. I'll completely assign it tomorrow, but at least you can get started on it. All right, have a lot of that done tomorrow. I'll finish up the lesson. We got like 2 examples plus one more theorem I got to talk about, and we're out of time today, so that's all I got time for. All right, so try to get as much of that done tonight as possible. It'll give you less to do tomorrow,